So we've been talking about using derivatives to help us determine where a function might be increasing, decreasing, where we might have a relative max or min, and also where the function is concave up or concave down. And what we want to do now, because we want to be able to use that information to get a graph of the function. And so we're going to kind of step backwards first. Here is a graph of a function f. And from this graph, we want to try to come up with the graph of f prime and f double prime, or the first and second derivatives. So let's start with the first derivative, which we know lets us know where the function is increasing, decreasing, and also where we would have those critical values. And when I do this, I like to start with the critical values. Of course, right here, where we have a horizontal tangent line, and also here, we're going to have critical values. So at these particular points, our slope is going to be equal to 0. So I'm going to put that in. I'm graphing f prime. And so what I know is that f prime is going to be 0 wherever I have a relative max or min on the graph of f. Okay, so I've got a relative max here. Okay, and so at this same x value, I would have a slope of 0. I have a relative min here, so at this same x value, again, I'm going to have a slope of 0. Okay, now what I'm going to do is look to the left and right of those points and determine if the slope was positive or negative. So if I start in this interval over here, we can see that the slope of the graph is increasing. So that means we have a positive slope. So positiveness would be above the x-axis. I'm going to graph coming down this way. Okay, so once I get to this point, then what does my slope do? We start to go down. My slope is going to be negative until I get over here, right? So, and then at that time, I've got to come back to 0. So we're going to have negative slope from here to here. Okay, we can see that again from this relative max. We're declining, declining, declining. The slope is still declining. So the slope is negative. It has some negative value. Negative slope means that we're declining. And then by the time I get here, I need to be back at 0. Okay, so between these 2 points, our slope's going to be negative. And so we'll just kind of do this. Again, by the time I get back over here, I have to have a slope of 0 again. But between these 2 values, we can see that the slope is decreasing. Okay, and then once I get to this point, we see that our slope is positive again, right? So here on the graph, we start to increase. And so the slope of f prime is positive once we go beyond this critical value. Okay, so that's the slope of, or that's the graph of our first derivative, roughly speaking. Okay, now what about the second derivative? Well, that talks about concavity. I'm going to graph this one in red. And of course, we know that concavity changes at the inflection point. So if I look at the graph of f, I can see it starts out by being concave down, and then it's going to become concave up. So somewhere halfway in between here, we can kind of say, okay, we're changing from concave down to concave up. Okay, and at that point, we know we're going to have a second derivative value of 0. Okay, that's not a critical value, but we called it an important point where we can change from concave up to concave down or vice versa. All right, we only have 1 point, so I only really need to consider 2 intervals. What's to the left of this point and what's to the right. And so when I look to the left of the point, we're talking about concavity. To the left of the point, this function is concave down. And concave down corresponds to having a negative second derivative. Okay, so it's going to be entirely negative. Okay, I don't know the exact slope of it. I'm not so worried about that. But what we want to be able to do is interpret the derivatives in terms of their graphs or what they tell us about the graphs. And then here, once I get beyond this point, the graph becomes concave up. So that would be positive. So we just continue it on this way. And so this is the graph roughly of f double prime. These aren't exact, they're rough sketches, okay? But we should be able to look at a graph of a function and come up with a graph of the first derivative and also the second derivative.